Have you ever used a piece of tech and just thought, how is that even possible? It feels like magic. Well, today, we're going to pull back the curtain on one of the key secrets behind modern, lightning-fast search, and it's called vector clustering. I mean, really, think about it for a second. You type dog into your photo library, and in less than a blink, every picture of a dog you've ever taken just appears. How on earth does it sift through thousands, maybe even tens of thousands of your photos that quickly? Well, the answer isn't some kind of wizardry. It's actually a really smart shortcut. A clever way for a system to find exactly what it's looking for without having to check every single thing. So let's get into it. How does this smart shortcut actually work? The whole concept is called vector clustering, and the big idea is surprisingly simple. It's all about grouping similar things together. You see, in the digital world, pretty much anything, a photo, a song, a document, can be turned into a string of numbers. We call that a vector. And clustering just takes all the vectors that are mathematically alike and puts them in the same digital neighborhood. To make this super clear, let's use an analogy. Imagine a huge library with millions of books just tossed in a giant pile. Finding one specific book would be an absolute nightmare, right? Well, vector clustering is like hiring a genius librarian to organize all that chaos. And this librarian has a simple three-step process. First up, partition. They create sections in the library, history, sci-fi, biographies. That's basically dividing all the data into clusters. Second, match. You walk up and ask for a book about space travel. The librarian instantly knows your query is closest to the center of the sci-fi section. They don't go scan every single book, they just point you to that section. And finally, step 3, the narrow search. Now you only have to look in that one aisle, not the entire massive library. And that right there is the whole secret. By cutting down the search space from, say, 1 million books to just a few hundred in one section, the whole process becomes thousands of times faster. It's brilliant. So that sounds pretty perfect, right? A flawless system. But like with any shortcut, sometimes you can take a wrong turn. So let's talk about where this elegant solution can actually fail. Which brings us to the big question. Is this method completely foolproof? And the answer, maybe not so surprisingly, is nope. It's a really powerful shortcut, for sure, but there are specific ways it can break down. This quote from the source material really nails the core problem. What if the book you were looking for was a biography about an astronaut? Our librarian sent you to the sci-fi section, but the book you actually wanted was in biographies. You'd miss it completely. In the tech world, we call that a loss of recall. This main issue can cause a few common problems. You get what are called boundary cases, where your search query is right on the edge between two different clusters. You can also get imbalanced clusters, where, say, the sci-fi section becomes so huge it's basically a library all on its own, which slows things down. And sometimes you just get poor clustering from the start, where the groups themselves just don't make a lot of sense. Okay, but here's where it gets really cool. Engineers know all about these potential problems, and they've cooked up some incredibly clever ways to fix them. So instead of just shrugging and accepting these trade-offs, they've built some ingenious solutions to get the best of both worlds, speed and accuracy. And for pretty much every problem, there's a corresponding fix. For those tricky boundary cases, the system can peek into a few nearby clusters. That's called multi-cluster probing. For those giant, imbalanced groups, they use better setup algorithms to keep things even. And to get the whole library organized better, they can use more advanced methods like hierarchical clustering, which is kind of like creating sections within sections. Let's look a little closer at that multi-cluster probing idea, because it's simple but so smart. Instead of the librarian sending you to only the sci-fi section, they'd say, hey, check sci-fi, but maybe also peek at the first aisle of biographies, just in case. So you search the most likely spot, plus its closest 1 or 2 neighbors. It takes a tiny bit longer, but your chance of finding the perfect book goes way up. So when you get down to it, all these fixes are about finding that perfect sweet spot between speed and accuracy. It's a deliberate trade-off. You give up a tiny fraction of speed to get a huge boost in making sure you find the right answer. And how accurate are we talking here? Well, with these fixes, modern search systems can hit over 99% accuracy or recall. Just think about that. More than 99 times out of 100, they find the absolute best match. And they're still thousands of times faster than checking everything. You really get the best of both worlds. And this really is the main takeaway.
Vector clustering isn't just about being fast for the sake of being fast. It's not a brute force approach. It's about being smartly fast by understanding the natural shape and structure of the data itself. So the next time your phone finds that one photo in an instant, you'll know. It's not magic. It's just a really well-organized digital library with an incredibly smart librarian. This tech is foundational to so much of our world now, from e-commerce to AI. But it does leave us with a pretty fascinating question to chew on. As our data gets even bigger and way more complex, what's going to be the smart shortcut of tomorrow?